In this video, we're going to look at properties of limits. The first property is a very straightforward one. It is the limit of a constant. So if k is a constant, and we're imagining the function f of x equals k here, then the limit as x approaches c of that constant function of the constant k is equal to the y values that the function approaches as you get closer and closer to c from both the right and the left. Either way, those y values are at k. They're always approaching k. So the limit as x approaches c of a constant is the constant itself. Next is the limit on, or theorem on limits of polynomial and rational functions. R stands for rational here. So if you have the limit as x approaches c of a rational function or polynomial function, you can take the limit by plugging in the value of c in for x. Okay? N is for numerator, d is for denominator, just to make it more clear. But essentially what you do is you just plug in that c value, okay, where it's equal to r of c. Plug in the x value in here. Because just like here, the limit is equal to the y value on the function. Same thing here, the limit is going to be equal to the y value on the function as long as you don't have a zero in this denominator. Okay, we can write that in. As long as d of c does not equal 0. Because if you have a 0 in the denominator on a rational function, then you've either got a whole or an asymptote. But everywhere else, that function is defined. So for this function, we can go ahead and just plug in 3 to find the limit. It equals 3 squared plus 4 times 3 minus 7, all divided by 3 plus 2. So we have, let's see, 9 plus 12 is 21, minus 7 is 14 over 5. Or in this example, you can kind of imagine the polynomial function x cubed minus 8. It's just a simple smooth curve. So the limit is going to be equal to the y value at 3. So it's simply 3 cubed minus 8, or 27 minus 8 is 19. And then we have several more properties of limits here. The limit of a sum or a difference can be split into a sum or difference of two limits. These can be used to simplify things. Technically, they are the foundation of derivatives, which is why we're talking about them. So when you learn about derivatives, this is the foundation for it. And this is not a really practical way to find limits oftentimes, however. The next property is the limit of a constant times a function. You can pull a constant out to the front of a limit. Okay? The limit of a product of functions. The limit of a product of two functions can be split into the product of two limits. Or of a quotient. The limit of a quotient can be split into the quotient of two limits. As long as that denominator doesn't equal 0, then it works. For the limit of a power of a function, you can pull the limit inside of the power. Or for a radical, you can pull the limit inside of the radical. Okay, and that's it for this video on properties of limits.